Okay, you guys, if this video goes dark really quick, it's because my Jimmy rigged phone on top of a Starbucks cup situation has collapsed. But here we go. Volume of a pyramid. All we are going to do, we are doing square pyramids. Okay, so that means that the base is going to be a square, hence the name square pyramid. So what we're going to do is the length times the width times the height, not the slant height. Okay, so the length and the width are always going to be the same because it's a square. And then the height is the vertical, like plumb line, like straight from the top down to the bottom. Now, if we were in class, and we will do it when we get back, what I would show you is that it would take three, if this was a rectangular prism, let me see if I can draw this. That looked like this. Okay, that was the same height. It would take three of these pyramids to fill up this rectangular prism. So the relationship is the length, the width, the height divided by 3. So just like when we had a rectangular prism and we did length times width times height, this time it's length times width times height divided by 3 because it would take 3 of these pyramids to fill up a rectangular prism with the same length, width, and height. So on this one, we're going to do 7 times 7, now I can't see that, times 4, I think that was a 4, divided by 3. So you're going to use your calculator. 7 times 7 times 4 divided by 3. And I got 65.3. We're rounding to the nearest whole number, so that's 65 centimeters cubed. On the next one, okay, it's a square, so the length and the width are the same. They're both 2. The height of this pyramid is 5, and then divided by 3. 2 times 5 divided by 3 is, I got 6.6 repeating, so that is closer to 7, so 7 centimeters cubed. And then on this last one, I know that the length and the width are the same. They're both 14, 14, and 14. Okay, and then I'm not using the slant height, right? I want the straight up and down height, which is 12. So 14 times 12 divided by 3, I ended up with 784 meters cubed. Okay, on the next section, for a cone, what we're gonna like essentially pretend, oh, that was really big, is that if this was a cylinder, okay, that has the same base and height, right? We know that we would do pi r squared h, okay? Oh, I should write it up here. But then it's the same relationship between a cone and the triangle and the square pyramid above. It would take 3 of these cones to fill up a cylinder that had the same base and the same height. So pi r squared h divided by 3. So it's kind of 2 new formulas, but it's really not. It's the same formulas as yesterday, length, width, height, and pi r squared h, and then we're just doing divided by 3. So pi r squared h divided by 3. Okay, so on number 4, we're going to do pi times 9 squared times 21, right? The height, not the slant height, and then divided by 3. So pi times 9 squared times 21, and then divided by 3. Can you see that? I got 1,781.2. That 2 is not 5 or more, so my answer is 1,781. There's no unit. We'll just say inches cubed. On number 5, we're going to do pi times the radius squared times the height divided by 3. So pi times 13 squared times 17 divided by 3. When I typed it all in, I got 3008.5. That 0.5 is 5 or more, so it's 3009 meters cubed. And then number 6, you can type it in on your own, but we're going to type in pi times 6.9 squared times 15.2 divided by 3. And I got 757.8 So that's 758 inches cubed. Okay, I'm gonna plug it in one more time just to make sure that I typed everything in right. So pi times 6.9 squared times 15.2 divided by 3. Yeah, 758. So there you go. Length times width times height divided by 3, because it would take 3 of these pyramids to fill up a rectangular prism with the same base and height. And then pi r squared h divided by 3, because it would take 3 of these cones to fill up a cylinder that had the same base and height.